All right. Hello, everyone. Welcome back. So let's talk about this activity. So my goal behind this activity was that you each applied this idea to the point that you were able to see that the relationship of one variable with another depended on which value of the other x you plugged in. And so I am now here to ask whether that made sense and to ask whether you had any follow-up pieces to that. I had one group that I visited that had an excellent epiphany. So they would be more than welcome to share that if they would be interested in it.
I guess I just have a general question, Dr. Logan.
Sure.
So I get how basically we have the two lines plotted showing the relationship between these and they're going to intersect at some point. And if you change the numbers in the equations, I understand that those equations are then changing. But why is the slope changing? So is it actually changing the relationship of those two lines?
Yeah.
Okay, so how does that work if you're actually changing the relationship? Because if you start with one equation, how does that equation change the way it's plotted based on the values?
So in this case, it changes because of the multiplicative term.
Okay.
Do you mean like how does it change in the math or how does it change
Mostly on the graph. It doesn't quite logically make sense in my brain.
Okay, let's see. So with something like this that we were just looking at.
Mm-hmm.
So what you're used to, what we did for a long time was when we were making graphs, we would just say, when this one is 0, let's plot a line.
Mm-hmm.
And then with interactions, you're allowed to plot more than one line. And what happens is that kind of like, what's that interaction example that we started with at the beginning? Like the hot and cold example.
Mm-hmm.
The relationship between how comfortable you are and how many clothes you have on is dependent on the weather.
Mm-hmm.
And so in an equation like that, it would look something like this because it would have an interaction term in the model so that when I'm talking about it being very cold outside, there's a positive relationship between more clothes and more comfort.
Mm-hmm.
But when it's hotter outside, when I'm at a high temperature like 100 degrees Fahrenheit, then there's a negative relationship between how comfortable I am and how many clothes I have on.
Mm-hmm.
And so by locating it in space, all that we're doing on a graph is picking 2 points
Mm-hmm.
of one of your variables, and then you're creating the line for the other one. So essentially, when you have a plot like that, I was going to try to draw
Okay,
something.
because it's just a representation of what the two lines are doing, not an actual this is the equation line magical thing.
Well, so every plot is a visual representation of an equation.
Mm-hmm.
0, 1, 10. So with something like this, can you see that,
Mm-hmm.
or should I unshare my screen? Let me unshare my screen. Stop share. So for something like this, which I should be bigger now.
Mm-hmm.
Hello.
Yeah.
There's the relationship. This is a one relationship. So this is b0, y equals b0 plus b1 times 1. And the reason
Mm-hmm.
we, that doesn't make any sense at all. Hang on. So the whole point of regression, remember, is to get an equation that represents a line
Mm-hmm.
to best fit a set of points. And the
Mm-hmm.
reason we have a line is because we have a continuous variable as our y, which means that at any point on x, no matter what it is, I can get an expected score on my y
Yes.
variable. No matter which x variable I pick, I can get a y.
Mm-hmm.
And that worked great when we had things like just two predictors, when we had education and number of topics of internet news. And then when we added another predictor, we could say, okay, for males, it looks like this, and for females, it looks like that. We
Mhm.
have two equations, one for when x is 0, one for when male is 0, and one for when male is 1. That's just me picking two values of x.
Okay.
Now, the only difference is that once I've added the interaction into the model, I'm not forcing them to always be the same distance apart. I'm not forcing them to have the same slope every time. I'm now allowing them to have different slopes because
Okay.
as I plug in one value for x1, the relationship of x2 with y can change because of
Okay.
that interaction term in the model.
Okay.
This guy. And the size of that interaction and the significance of that interaction, but the size specifically talks about how much it changes across that distribution.
Okay. Thank you.
Yeah.
I would be happy to explain our group's epiphany if you think it would help.
Yeah, go
Dr.
for it,
Levy.
Abby.
Okay. So essentially we were talking about trying to interpret the new relationship in words with the reduced equation. And essentially we were realizing that it is that instead of saying when x1 is 0, you're saying, okay, I'm going to say that I'm going to pick 50. So when x1 is 50, the relationship between x2 and y is such that a 1 point increase or decrease on x2 is associated with this coefficient increase or decrease in expected outcome. And so the two lines that we're picking are not just changing when we're selecting values of x2, but the entire line is just a whole new line. And so if you pick 50, where the value starts on this part of the graph depends on what value you pick for x2. So if you said 1, then okay, your coefficient in this case is 0.25. Then when x2 is 2, then it should be 0.25 higher. And then when you pick a different variable, that's telling you, okay, but the coefficient is different over here, which is why sometimes the spacing is different at different values of x1. If that helps anyone.
Fun.
I have a question.
Sure, Jonte.
Can say if you have two variables that are found not significant, is there a possibility still that an interaction can be found significant, and what is the likelihood of that?
They are unrelated, so totally likely that that could happen.
How is that interpreted then, I guess?
So, just like so whenever there's an interaction in the model, remember you can only interpret each main effect, which is like this education and this party line. You can only
Mm,
interpret those at the 0 value of the other
mm,
because of exactly how this changes when you sub in more information about what your x1 is.
mm.
So I think wasn't one of these examples? No, unfortunately, I put all significant examples here. But remember, so for example, we could have one relationship of x with y that looks like this. It's negative. So this is maybe, let's say this is what New Zealand cats. So for my New Zealand cats, there's a negative association between whatever x1 is and with y. And now my Australian cats, maybe there's a positive relationship for the cats from Australia.
Mm.
Now, on average, that's going to look like there's no relationship.
Mm.
If I have half the cats from New Zealand and half the cats from Australia, if I take the mean, it's going to look like there's no relationship there. So that's a reason why you could have a non-significant main effect, but it could be significant once you put in the interaction. Or probably more likely, and what will happen a lot, you'll probably see a lot, is that once an interaction is in the model, so that right there is a slope of 0. As x1 goes up, y does not change. That slope is equal to 0. It's going to be not significantly different from 0. But my other line right here could have a positive slope. So if I have centered it such that, say, this is New Zealand and this is Australia, there's no relationship for New Zealand cats, but there is for Australian cats. So if I've centered it such that New Zealand is 0, then this x1 variable, so what's that, curiosity? It's curious. So my x1 variable is curiosity. So as curiosity goes up, there's no change in y. And then if I have centered it here, if I've centered, what's this called? X1, this curiosity variable, if I've centered that somewhere in the mean, there's no difference between my groups. But there's still a significant interaction in this model.
Right.
Because it
That makes sense.
depends on where you're going to put stuff, where you're centering things, which is why we have to locate it exactly in space. And this is why we have to run the regression when we pick a point. Yes, Michelle, you've got it exactly. That's what we're doing here, is picking points.
That makes sense. Thank you.
Yeah. Let's see. Nina, what you got?
Okay, so I'm not sure if this is gonna make sense, but would it be possible? I think that I have a little bit of trouble with the cats in New Zealand because conceptually it doesn't mean much, but which I mean it's a fun example, but I think like that just makes it a little harder for me. But can I ask, like, so in the, and I'm sorry to call out whoever I peer reviewed this weekend, but she had a really like an interaction that made a lot more sense to me, which was about income level, sex, and political party. So that one I think makes a little more sense because traditionally women skew more Democrat and or women at least skew more liberal than men. And as you move up in terms of like income brackets or like amount of money made, you also, or you tend to lean more Republican traditionally, right? So in theory, if you were looking at like the interaction between, or like the moderation between like income level and political party, maybe you would see like when you move from male to female, like men don't change as much as they move up income levels because they're already leaning more conservative. But with women, as you move up income levels, there's like a steeper slope because there's like a more drastic difference, I guess, since they tend to start more liberal. Is that, but like how, I still don't really understand how that's like explained when you do the multiplication. I just feel like I can visualize those two lines in my head, but I'm still having a little bit of trouble with like the picking specific points and how the like multiplication speaks to that. But like when I was reading that example in the homework, I was kind of like, I get those lines, like that makes sense to me how that would look. It's just like when I try to sit with the numbers that I get a little more confused again.
Sure. Who did this example? Does anybody feel comfortable talking about it? And if not, we can get another volunteer for a better example besides cats from New Zealand. I unfortunately don't remember who it was.
I mean, I do. I just didn't want to call them out.
You're not allowed to, sorry. Okay, so then who else has good examples? What were we just looking at? Patrick, you had a good one. Would you be willing to share yours? I'm allowed to call people out. You're just not, Nina.
Sure.
That's fair. That's why I didn't say it in the first place. I just want to be very clear that I never had any intentions of calling someone out without your say so.
I only know because I dropped into Patrick's room and he walked through his example. So I will, oh, whoops, hey now.
So,
I'll just take notes while you write. Or
where
while
do you want me to
talk.
start with mine?
Would you tell us what your predictors and your outcome are?
Yeah, so my predictor was, my two predictors are the total number of adverse childhood experiences that someone experiences. And the other one is their age when they take the survey. And the outcome was the impact, the cumulative impact of those, of their adverse childhood experiences.
How is that quantified? I forget. What does that represent?
So they, it's, I think 0 through 4 for each individual item, and then they can just get a total score at the end of the survey. So 0 would be
Impacts.
no impact.
Oh, so they rate like how this
Yes.
impacted your life.
Mhm,
Gotcha,
for
gotcha,
each
gotcha.
specific ACE.
And you said it ranges pretty highly, doesn't it? Didn't it go up to like 50? Or was it 22?
I think the highest was like 77 or something like that.
Okay.
Yeah.
All right. So this is, so it's self ratings
Hmm.
of how these childhood experiences have affected you.
Hmm.
So the idea being that maybe if you had these adverse childhood experiences when you were 2 and 3 years old, and now you're 60 years old, you won't feel like they had as much of an impact on your life.
Potentially, yeah.
So that's the sort of question that we're asking is, does the sort of severity or total number of ACEs reflect or predict their cumulative impact? And is it moderated by how old they were when they took the survey?
Hmm.
I'm curious to know if that example makes more sense to some folks than New Zealand cats. Maybe it won't matter. Let's do it anyway. Okay, can you tell me what the coefficients are?
Yeah. So the constant is 5.829. The total number of ACEs, does it matter that I centered them? Should I tell you that?
Yes.
So I
What's zero?
centered the ACEs at 15. This is the mean.
Okay.
And the age I centered at, I have to scroll up. I think it was like 21,
I think it was 22.
22. Yeah.
Okay. So we have two things. So the B1 for ACEs was what?
2.221.
Okay.
And then negative 0.115.
Uh-huh.
And then the interaction.
Whoops. B1, 2.
0.031.
Okay. So here we have the relationship among all of these predictors here. And so what the first thing I notice is that when ACEs and age are both at the mean, our self-rating cumulative impact is almost 6. That's what this intercept is representing. When both of these are 0, this is about 6. So pretty low cumulative impact, it looks like. If it ranges all the way up to 77. Now, the question was, as we are, so if we're holding age at 0, so for 22-year-olds who are filling out this survey, the relationship between ACEs and our outcome, the cumulative impact, is about 2. So for every additional ace, that's another score of 2 on that impact. But as I'm going, so let's say any 2 people here at 0 on aces, one who's gone up by 1 on age, that hypothesis was correct, that there's less of a rating of cumulative impact. But only at that point, only when aces is 0. Because this interaction is also significant, which suggests that as one of these changes, the relationship for the others are going to change. So let's do that equation and then math it out. So we're going to have y equals 5.8 plus 2.22 times aces plus, it's actually minus 0.115 times age plus 0.031 times aces times age. All right, so I've harvested the equation. And then which one of these did you do, Patrick? Can you remind me? Because I know you plugged in, I think you plugged in a number for age.
Age, yeah.
Okay, so I'm gonna
Actually, no, sorry, I didn't. I did it for aces.
Okay, that's right. So I'm gonna remind us we have 2 places where we're going to change this expected score for aces. So you plugged in 1, I think, was that right?
I did 1 the first time and 10 the second time.
Okay. Let's go ahead and straight to 10. So 2.22 times 10. And then I'm going to put 10 here also. And then when we reduce this down, what does that get us to?
28.039 plus 0.195 times age.
Okay. So, and this is where what I think you found so interesting. So why don't you talk to us about this takeaway about the difference here for the age variable, for the age
Yes.
coefficient.
So it switched to a positive relationship. Yeah, the first time around, it had been a negative relationship, but then when you increase it by 10 aces, there's a positive increase, even as they get older.
Okay, so at first, there's a negative relationship between age and the number of aces. So as you get older, you just remember fewer when aces was the mean. But as you go up by 10 aces, that's more severe, more aces happening in your life, then the impact increases with age. As age goes up, the perceived impact is also going up. The perceived self-rating of cumulative impact is also going up. And so if I'm graphing this, I can make 2 lines. I can make one line here relating age. So I can make, this would be the first line when when aces is 10. And then I can also do a line when aces is 0. That we did weeks ago. When aces is 0, that line is going to be this comes out because it's just 0. So here is the first line I would plot. It would cross the y-axis at 5, and then it would go down with age. As age goes up, the expected score on y goes down. And here's the other one. when aces is 10. Now it's crossing the y-axis at 28, and it's going up from there. So that's how I get two lines from the same starting equation, depending on which variable I plug in. And it's entirely only due to the fact that I have this multiplication of the two values by one another in the model. Without that there, it would not, you wouldn't be able to see that change. And I see people are talking now, so hang on, I'm going to stop talking. Check. Okay, my chat isn't showing up, so someone's going to have to be my chat monitor and tell me what it says.
I can tell you what I said. So I just was asking if the two lines would kind of look like a less than symbol, except like open at one side.
Yes, that's exactly what it would look like.
Okay.
Well, I'm not,
And then-
well, because one's going to start up higher. Yeah, open
Yeah.
on both ends. So it would look kind of like
Right.
this.
So one starts higher and like starts high and gets higher, and then the other one starts low and gets lower, right?
And gets lower.
Okay. And then the other thing in chat, Chloe says, so that's why we pick a point to see if the relationship changes.
Yes, and that's exactly what we just did. Picked a point to see if the relationship changed. And I think some people have chatted me privately then. And I'm sorry that my chat box is no longer functioning. It's just hiding. Let me try minimizing everything and then coming back up. Aha! Okay. I think we got it. Thank you so much, Patrick, for sharing that with us. I appreciate it.
Yeah, can I ask a quick follow-up too?
Yeah.
So with this, we would first run the analysis and we would get our chart and see if there's a significant interaction.
Yes.
Once we find out that there is a significant interaction, it's wise to then pick points to see how exactly the relationship changes. Is that when you would do this picking a point?
Yes.
Okay.
You don't need to pick a point if your interaction
If
is
it's not.
not significantly different from 0. Because
Right.
that's telling me that it might look like they're not, because this is why I let you can plot it anytime. It can always look like it's not parallel, but it's not parallel. It's not different from parallel enough that it would be significantly different from 0.
Dr. Logan, I have a question about
Yes.
the B weight or slope for the interaction term.
Uh-huh.
So sometimes it changes like no. So sometimes the interaction term, sometimes they are positive or sometimes they're negative.
Mhm.
So is there a way that we can interpret the interaction term slope?
Sure. So first is you can never interpret the interaction term by itself. It only exists to talk about how one slope changes when the other value changes. And so in this case, what I can say is that as age goes up, the aces score, the slope of aces 2.22 is going to increase by 0.03 for every unit of age. And I can do that because if I just look at how the equation works, if I plugged it in 1 for, in this model, if I plug 1 in for aces, or if I plug in 1 in for age, sorry, then I'm going to add in this interaction term. And so it really only exists to be interpreted alongside the other two main effects. You can interpret it globally in order to say that the relationship of one of these is moderated by the other, or these two moderate one another in relationship to the outcome. You can say that. But in terms of a 1 unit change in the interaction, there's no such thing.
Okay, I see. Thank you.
Yeah, you're welcome. So I book on my calendar, I always book 3 weeks for interactions when we meet in person. And so we have 4 weeks when we're meeting not in person. And I still think it might not be enough. We may need to do one more. We'll see. We'll see how it goes. Okay. Did I
Can
get
I
another chat?
question?
Yes, please ask.
When we're picking values, should we be picking something very extreme? Like if part of what we're trying to figure out is if there's a change in relationship, does it make most sense to go more on the extreme end as opposed to picking like a smaller value that might be less likely to demonstrate a change in relationship? So like in this case, starting with 1 didn't demonstrate anything, but showing with 10 did. Is that should be thinking about?
That's a good question, Krista. You know, I think it depends on how likely those are. So I wouldn't pick an extreme value if you really don't have anybody up there, because then you're like interpreting an interaction for people that don't really exist. But yes, usually with a pick a point approach, what I typically see is people who select 1 standard deviation above the mean and 1 standard deviation below the mean to test, because still then you've got a good chunk of your sample at both locations. Sometimes people will go as far as 2 standard deviations from the mean, or pick an extreme value as long as they know that there are people there that are represented. So that would be my suggestion. In terms of your understanding of how the interaction works, just for your own like fun evening time, because you know that's what I do on my fun evening time. Yes, you can pick the most extreme values you want. Sometimes when I'm just really trying to understand why does this interaction look significant when I'm plugging in these probable values and it just doesn't look very different, I'll just put in like 150 when it's not even a possible value, just to see what happens to these lines as I extend them out into eternity. I don't report those in my paper, but it might help me understand what these slopes would look like at extreme values to sort of understand what the interaction's doing. This is fun for me. Okay, I have, oh my goodness. We're like almost out of time. That is very sad. Let me run through these pieces here. We've got like 20 minutes left, but that's what I mean. It's like I feel like we're almost out of time. Okay, well, let me run through these next pieces because I think that they set us up for the they set us up for the rest of this really nicely. For the rest of the class. All right. So this week on the schedule was moderation and mediation. And the only reason that I'm gleaning to dive into it after the brain bending that we just did for the last hour is because you're going to figure out that you already know what both of these are. And that's why I'm going to do it. A moderator, I've been using the term moderator all along to talk about interactions. So that should give you an idea that you know what a moderator is. Sometimes when people set up a moderator model, they'll picture it like this. I find this graph to be very confusing and I don't use it, but sometimes people use them, so I'm showing you what they look like in case it makes sense to your brain. You have a predictor or predictor 1, you have a moderator or a predictor 2, and then you have the interaction between the two. And all 3 of them are predicting the outcome. This is all we've done today so far. The moderator hypothesis is supported if path C here is significant. And that just means if the interaction term is significantly different from 0. But just like we talked about with interaction models, you can't just put the interaction in, it has to be all 3 of the variables. Variable 1, variable 2, and their interaction. You may also see significant main effects of your predictors, but remember, those are specific to a point in space or time based on your values of your other moderator variable. And you just did this because any interaction you do is a moderation model. Any one you do at all. And so I have this question here that I'm phrasing in terms of moderation. Does TV time or screen time moderate the relation between ability and achievement? Or does the relation between ability and achievement depend on the time you spend watching TV? These are not new. It's just sort of thinking about it as moderation might be new because I used interaction terms at first. That is all I'm going to say about moderation because you already know how to do it. You literally did a moderation for homework 7. That's what it was. What you haven't done is use the process macro to explore the moderation, which should be what you get to do in lab tomorrow. So what I'm going to spend the rest of the time on is mediation. Theoretically, you all read the Preacher and Hayes article and the Barron and Kenny article, which were both in the readings for today. They introduce the 2 different approaches to mediation. And I think Preacher and Hayes actually reviews the Barron and Kenny method. So you may have had that option. So there's really 2 different ways that people measure interactions. The original method is this Barron and Kenny 1986 method, but I'd be willing to bet that method is older than many of you. And so people still love to cling to their methods that they know very well. But this new method, the Preacher and Hayes method, has sort of taken over a little bit more. I'll talk a little bit about the differences between the 2. This is the basic setup of a mediator model. You have a predictor, you have a mediator, and you have an outcome. The test for mediation in the Barron and Kenny method is conceptually pretty straightforward. You follow a 3-step process. In step 1, you show that the mediator is predictive of the outcome by running a regression with the mediator predicting the outcome. In step 2, you show that the predictor is associated with the outcome. That's the second step. It's another regression. And then in step 3, this third regression, you include both the predictor and the mediator in predicting the outcome. And then you look, the difference is between what happened when the predictor was the only predictor in the model and compared to once the mediator was in the model. What's the difference? Sometimes they call this path C prime because that's what they called it in the original paper. If that path C prime is not significantly different from 0, they will call that full or perfect mediation. If it's less than it was in the previous model, then it's going to be partial mediation. But if it's the same as it was before, then no mediation occurs. And the whole idea here is with a research question like this, you're trying to determine whether the relationship between the predictor and the outcome is explained by this other thing. I have this relationship between an X and a Y, and I want to know if this other thing is actually the reason why this X is related to Y. And I'm going to call out Hadley because she sent me an idea about mediation, and I just wanted to clarify. Can you explain your mediation hypothesis?
Yeah, I can try. Although I get confused the more I talk about things. So my predictor is the percentage of non-white students in a school district. The outcome is the school district's performance index letter grade. And the mediator is average years of teaching experience in the district. So yeah. And then I think if I talk more, I'm going to get confused.
Nope, you're exactly right. So then I'm going to take over, which is the idea being that the percentage of non-white students has historically been associated with the grade of the school. And your hypothesis is that that relationship would be explained by the fact that those schools tend to also have much teachers with much lower experience, much less experience. And so that relationship may be diminished or go away if you just account for the lack of teacher experience in some of these schools.
Yeah, and I already know that path A and path C are significant. I can't remember if path B is. I need to double check that. I think it is.
Yeah, and I think I overstated the importance of path B. It's really just this model with this as the only predictor, and then the model with all of them as the predictor. Now, this path A is represented by the fact that you have just both of these predictors in the model at the same time, because one controls for the other. They're correlated within your regression model. That's how the math works.
So Dr. Logan,
Yeah.
when you're putting in both the predictors to find out whether it's mediating, do you run a multiple regression or a hierarchical regression?
Yes. You do
Oh,
both.
both? Okay, cool.
Because
Okay.
wait. Here's how you would do it for, I'm not going to do this. You would do it in 3 steps. If you're comparing path C, which is when you just had one predictor in the model, to that prediction when there's 2 in the model, it might seem familiar because it's just a hierarchical regression. It's just a multi-step model, but in step 1, it's a single regression, and in step 2, it's a multiple regression. And so all you're doing, remember when we introduced hierarchical regression, I said, have a look at what changes when you take out or put in predictors in your second step. That's exactly what this is designed to do. You're looking to see, if I control for this other thing, does this relationship go away? So you do that with a hierarchical regression. That's all it is. And so Preacher and Hayes, just to alert you to what it is that they're focused on, because you'll get a chance to look at this. It's the same idea. In this case, I'm looking at the relationship between ability, whatever ability means, TV watching, and achievement. Now, with Preacher and Hayes, they're ignoring path C. They don't care about diminishing path C. They think that's not very interesting. They're more interested in, does the relationship between ability and achievement flow through or go through this mediating variable? Is ability only related to achievement through amount of TV you watch? That honestly makes absolutely no sense as a hypothesis. So I really like Hadley's example better. Is the only reason that percentage of non-white students is related to the grade, the failing grade or not so failing grade that the district gets, is that only related because non-white students is predictive of the number of, or the percent of teachers who are highly experienced, which is then related to achievement? So you're thinking about it in terms of how this relationship is flowing or moving through the pathways. So it's a little bit different, but it's the same. And it's the same in terms of it's just a hierarchical regression, sort of mathematically how it works out. Now, the process macro that you will learn about tomorrow in lab will walk you through both mediation and moderation. So you'll learn how to do both of those things in the macro, which is pretty handy. But what I want you to focus on now, and for the last minute, is what I've done is I've looked at moderation and mediation questions. And I've written out sort of conceptually what each one of these sort of asks. I'm going to not go into that because what I want you to spend your last 5 minutes on is writing a question yourself. So here I have compared the moderation model to the mediation model with the concepts of science score, screen time, and hours of homework. The moderation research question here is, does the amount of screen time moderate the relation between homework hours and science achievement? That's what all of this is saying in lots of different ways. Now, the mediation question is, does homework hours mediate or explain the relationship between screen time and science achievement? That one makes no sense to me whatsoever. This one makes a little bit more sense sort of conceptually with my research questions about screen time, about my constructs, screen time, homework hours, and science. And I think that illustrates that for you, pick 3 constructs right now, 3 constructs that you've been playing with. And I want you to think about a mediation question and a moderation question. One of them is probably going to make more sense for you. So I want you to think about crafting one of the 2 of those yourself. So I'm going to give you about, I know it's not very long because I really want to let you get out of here on time. So I'm going to give you about 5 minutes to think about that. And then I do want to put you back in groups to talk through your question to see if it makes sense. Let me see if I have a slide where I compare the 2. I said 10 minutes because I thought we'd go through the last bit faster. Let me find a good slide to share with you. So if I change this and I say, all right, there are the 2 example research questions. Okay, that's our time up. What I'm going to do is I'm going to say thank you, and you can go now if you would like to. Otherwise, I'm going to open up some breakout rooms so you can workshop your question. I expect that many of you may have a question like one of these in your final project. If you don't, then you can workshop your final project question with a partner or two when I pop you into a room here. And I'm going to monitor those rooms. And if I see you're by yourself, I'll switch you somewhere else if people leave. Otherwise, thanks for joining me. Have fun reading. Have fun in lab tomorrow. And I will read that private chat to me in just a second once I say, see you later, and open some breakout rooms. Thanks, everybody. Whoop. Who's that? Michelle, you mentioned that we could run multiple interactions at one time. My research question is going. Oh, okay. I'm going to stop recording now. Okay, bye, everyone. Maybe.
Hey, Dr. Logan.
Hi.